Very good morning to everyone. In this lecture, EC 8, 8791 Embedded and Real Time Systems, Department of Electronics and Communication Engineering. In previous session, we are discussed the introduction of embedded system and also the what are the design process and what are the design methodology, and then processor architecture of embedded system design and how to the program we are modeled and optimized the software coding techniques. Now in this session we are discuss the real time operating system for task assignment and scheduling process. First of all, a task, it requires some execution time on a processor. Is a quick time operation. It is a specific time. So it also a task may require certain amount of memory or access to a bus. Sometimes a resource must be exclusively held by a task. In other cases, the resource may be exclusive or non-exclusive, depends on the operation to be performed on it. So the task, it is a real time operation. That is, a task is a time at which all the data that are required to begin executing the task are available. So we need the deadline. The deadline is the time by which the task must complete its execution. So the deadline must be hard or soft deadline. So here the tasks are classified as a periodic or aperiodic functions. So we have to consider the levels, that is programming levels and also the implementation levels. In this case, the periodic, that is a task, it is a periodic, it is realized periodically, that is a second, that is a period of task in the timing interval. In aperiodic, the task to be those tasks which are not periodic and which also have no upper bound on the innovative rate, that is a special functions. So we have to check the task assignment or scheduling. So we have to move to the task assignment. All tasks start after the release time and complete before the deadline. So this is a yes set of processor into the time. It is a set of task. So a schedule may be pre-computed, that is a offline scheduling, and dynamically it is a online scheduling. In pre-computing, that is offline scheduling, it is nothing but it is advanced the operation with the specifications of periodic task will be a run and a slot for a different task in the event are involved. In online tasking, that is online scheduling, it is a dynamically scheduling. In this task are scheduled or they arrived in the system. The algorithm used in online scheduling must be fast and it takes to meet the deadline clearly unless. So there are the two types of priority algorithm are used. Number one, the static priority algorithm. Number two, dynamic periodic algorithm. In static periodic algorithm, It assumes that the task priority does not change with a mode. So the processor we have to execute in different mode 0, mode 1 and mode 2, or we have to choosing the different variety of processor, depends upon the processor. So the execution time of each individual task, it must compiled and simulated in specific periodical time. Here we are using the rate of monotonic algorithm and the dynamic priority algorithm. It is a algorithm assume that the task priority can change within a time. Examine the earliest deadline first algorithm, EDF algorithm. So we can see the classical uniprocessor scheduling algorithm. It is one of the example for rate monotonic scheduling process. Here the make an allocation and schedule each processor based on the allocation. Then are all these schedules feasible? That is a output schedule and check stopping criterion and declare the failure. It is a stop to declare the failure conditions. And in case the check the stop criteria, it continues to change the allocation of the scheduling process. So these are the flow graph of task and scheduling, task assignment and scheduling process. So in this lecture you have to discuss the estimation, that is a task assignment and scheduling process in embedded system design. Thank you for watching this video.